Hello everyone, and I knew it. I thought I was going crazy the other day when I clicked on using open broadcasting software, or whatever it's called, OBS. It keeps switching the desktop audio and the mic auxiliary, which is obviously the microphone versus desktop audio. So desktop audio is useful for when you're doing a multicast, so you've got lots of people, but it keeps swapping them around depending on what day of the week it is, I guess. It swaps them around, so sometimes you'll automatically just click on the one that's at the bottom thinking it's the mic, but it's actually the desktop audio. So you can be chatting away for half an hour without realizing no one can hear anything because reasons. Anyway, so hello. Today is morph-o-matic madness. So this is a continuation of what we were doing yesterday, or looking at yesterday, and trying to get morph animations to work with IMVU. And through various experimentations that did not involve Frankenstein, it turns out that suspicions were correct. It is to do with the mesh having an edge split modifier assigned to it. And that causes problems for FBX. Hang on, just chat. Miyaka it's showing you adverts before you start watching. Yes. Dun 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 dun. Well, on the, yes, I have little control over whether the adverts appear or when they appear. I mean, I know that you can do it, but I've got everything basically on the default. So whatever Twitch deems appropriate for advert placement, Twitch will place adverts, I guess. Yes. So Juzoi. I don't. Oh well, yes, that might be it. If you yes, so subscribers. If you are a Prime subscriber, I guess they disable or they don't show adverts. So if your subscription lapses, you become an ordinary pleb, a proletariat. Way, thanks very much for that. Subbed up. So yes, you become an ordinary prole. Yes, so I'm not quite sure how you pronounce your nickname, Juizoi. But yes, you can use auto smooth, but the problem with auto smooth is it's not well, I say it's not controllable. Obviously, it is controllable through angle, but it's not always applicable. So you can use edge split and edge seams for more control over where your smoothing or your smooth groups appear. But either or, it's personal preference, I guess. Just call you Tom. Is that Tom short for Bob? Yes, yeah. So either auto smooth or edge split, either or. So yes, what we were doing yesterday was trying to figure out well, Tom, Technically, no. That's not technically correct, but that's we were talking about that yesterday. That for all intents and purposes, in terms of using edge split and smooth groups and all that sort of stuff for IMVU, what they all do, it doesn't matter what technique or method you use, they all result in split vertices. That's how edge split. That's how smooth groups work. Unless there's a proprietary system in place, for example, I think Unity. I know that Unreal does this, but they can use, or they understand 3D Studio Max's proprietary system for smooth groups, so they can keep vertices intact when an asset is imported, but at render time, when vertices are rendered, when faces are rendered, at render time, they are split to create the vertex groups. There's no way around that. That's technically what has to happen. But what you do, or how you achieve your smooth groups in terms of what you want your mesh to appear as in Blender or 3D Studio Max, there's different ways of doing that. But at the end of the day, vertices or vertexes are always split to create hard, soft edges. No, it's not. That's the thing. You can't create a hard edge without splitting a vertex, unless you do something. I mean, this is how 3D Studio Max and Blender do what they do with edge split. So, I mean, technically, what's actually happening? We were discussing this yesterday. What's actually happening? So using the edge split modifier in Blender, and smooth groups is the same in Max, it keeps the mesh intact. But this is a proprietary way of drawing the structure to screen. But in game engines, they reduce everything down to their most basic elements. And in a game engine, or they used to, I mean, again, if they don't use proprietary smoothing tech, what's happening is this. It has to split the vertex in order for there to be a hard edge there. Otherwise, it's all treated as a smooth surface or a continuous surface, and there's no way around that. That's how this stuff is rendered to screen. Oh, in the in the FBX file, I mean, again, so you're now talking about data structure, as in the format of your file, and how the data is formatted in the file doesn't necessarily equate to what is rendered on screen in IMVU, for example. So I mean, you're right in that auto smooth or the edge split or smooth groups, they're all different ways of doing the same thing within a software application. But from the point of view of how that then translates over into what we see in a game engine, it's completely different, because the end result, the end goal, is different in a 3D application like Blender than it is in a game engine like IMVU. And in IMVU's particular case, because it's using such old technology, I think the engine, I can't remember the name of the engine, but we're talking about a technology that's almost 2 decades old. It was old when IMVU first started using it, because it came out of it goes back as far as the Quake 2 game, if you know that. old. It is very old, as Miyaka is saying in capitals. Well, that's what we're here for, Tom. It's always just educating and learning. It's not about proving someone right or wrong, or as you might find with other places. It's just always about education, always about learning. Right, so getting us back on topic. So what we were trying to do yesterday was add a morph or shape key animation to our little harter bike. Now, our previous attempts at export import, so that's export from Blender as an FBX and import into IMVU as an FBX file, didn't work. So there should be whoops, wrong one. There should be a morph animation playing on the exhaust, but we couldn't get it to work. It didn't matter what we were trying to export it as or how we exported it. If there were an edge split modifier assigned to the mesh, it's not on this one, so let me just open. That's 2018, I think it is. Right, so if there were an edge split modifier assigned to the mesh for some reason, so we've got a simple animation, just a morph of the exhaust putting or whatever noise that would make. It doesn't matter whether you export to FBX with the apply modifier setting disabled. Use my the apply modifier setting disabled. It doesn't matter if that's disabled. For some reason, the FBX exporter treats the mesh as if the modifier is applied after the fact, and if that happens, it destroys any morph animation that's assigned to the mesh. I don't know from the point of view of because obviously you're now starting to get into the more technical aspects of what's actually going on within an FBX file, or within any file actually. Is the data is structured in a tabulator form, so a cube has however many sides it has however many edges it has, and it has however many vertices it has. So you've got your 2 vertices make an edge, 4 edges make a face, and all of those are the data is structured so you have vertex 1, vertex 2, 3, 4, and on you go down the list. Logically, you would expect it to be listed numerically in order, so 1, 2, 3, 4, 5, but it doesn't do that. It orders it in often random order. But so long as all the data is valid in terms of all the vertexes that make up a cube are all present, the cube will be drawn. But if anything changes that order after the fact, it can cause problems. So with morph animations or shape keys, if the edge split modifier is active whilst you are assigning your morph, let me just switch. So we've got our little morph animation. So even though that works and that's valid, because the mesh has an edge split modifier assigned to it, when the mesh is exported as an FBX file, it'll destroy all of this because it changes, as you point out, it changes the vertex structure of the mesh. We kind of we went over this in a little bit yesterday, that the morph is only working as it is because each of the vertexes is known to Blender or 3D Studio Max if you're using Max. They're all known coordinates, and they're known. So there's 1, 2, 3, 4, 5, 6, 7, 8. So let's say there's 8 vertexes there, and Blender knows the position of those relative to the morph animation. So you can change it. But if you have an edge split modifier, and I suspect, although I've not tested this, auto smooth will do the same thing, because that's an effect. That's a function that is applied after the fact or during export, and when that happens, it changes the order or the structure of the vertexes that's associated with the morph, and it just breaks it. And that's what was causing our problem yesterday. As you're asking, yes, this is what we were trying to, after the stream. So we've got a simple morph, and this export's broken because it has an edge split modifier in place. So for IMVU, if you want to use morph animations at all, you're basically going to have to make your objects, so whether it's the heart of bike in this instance or just something like a simple couch. I mean, interestingly, Blender knows where all the vertexes are in relation to the morph animation, because, as we've just been saying, theoretically, this front section that we split off from the rest of this couch shouldn't be morphing, but it does because Blender knows what the vertexes are, or it knows it must tag them in some way. So if there's even though these vertexes along this front edge, have been split, so we've now got 2 sets of them, Blender has tagged them as a pair in a sense, and it knows that both sets of vertexes are or relate to the morph. But on export, that feature, function, ability, whatever you want to call it, is lost. If auto smooth, or again, haven't tested the auto smooth, but I'm going to assume. So if auto smooth, but more importantly, if the edge split modifier is assigned, because those will be applied on export by default, it seems, and that's what's breaking the morphs. So in order to get a morph animation out of Blender into IMVU, you have to create your mesh, set up all your do I have an earlier version? So that's 18, 17. No, that's the same. Okay, so I'll just use, what's 19? minus 25 Fahrenheit. Just reading the chat, shouldn't do that whilst streaming. Off topic. Right, so to get your object to export, make sure that any morph animations are removed. So that's any morph sequence. So you've got your morph, your action in a sense, your morph action. You need to delete, whoops, wrong one. We need to delete all of this, all of it. So there should be no animation, morph animation associated with the mesh at all. Right, so no mesh, no morphs. We want our smoothing to be kept, which is the edge split modifier in this case. So we go into our modifiers and just click apply. And that's splitting, or that's applying the modifier. So that now means that all of these groups are separate now. They've been split. And that's what smoothing is. It's just the creation of groups based on vertex assignments. But with that now in place, what you can now do is add your morphs. So to add your morphs, we're in object properties, and we need to be in the shape keys. They're called shape keys in Blender, not morphs. Shape keys. Click the plus button, and this is our basis. This is the root or default. It's the equivalent of the avatar's T-pose. Well, yeah, I mean, because of the way that smoothing works, auto smooth, although I'm not going to test it right now, auto smooth will do the same thing because it has to. That's how, I mean, as I mentioned earlier, that's how smooth groups are created. They're created by physically splitting the mesh or splitting the vertices. And that's what IMVU is looking for when it creates smooth groups or smoothing, controlled smoothing. Right, so we've got our basis group, and that is the position of the mesh as it currently stands. So that is essentially the idle position of the mesh. Just closing that. Right, so what we then need to do is add, in this case we'll just add 2, so click the plus button twice, and we've got 2 keys. We can rename those, double click, and just call them shape 2, whoops, lowercase, and shape 1. They can be called anything. Yes, I mean, the way smoothing works, it has to split the vertex. Otherwise, it doesn't know that there is an edge there. Even when you do it sort of in a proprietary fashion, like Max's smoothing or using the edge split modifier, what's drawn to screen is, for all intents and purposes, a set of split edges or split vertices. Otherwise, it just treats everything as a continuous or contiguous surface, and there is no split. There are no splits. There are no groups. That's how smoothing works. So at render time in a game engine, that's what's going on. Everything is reduced down to its core components. So that's vertices, edges, and triangles. Not polygons. Polygons are the next step up, if you like. But the core components are vertex, edge, and triangle. And how those relate to one another is determined or determines smooth groups. That's it. That's how it works fundamentally at rendering. But the fact that you can use or import 3D Studio Max smooth groups in Unity and Unreal might give the impression that they are doing something special, in effect, when they're not. It's just essentially the smoothing system is essentially just data organization in the file itself and the way that you interface with the programs. But at render time, everything has to be split up, or it's a continuous surface. That's literally how it's done. So you're saying that there's no difference between an edge split and auto smooth? No, technically, no, there isn't. They're just different approaches to doing the same thing, and this is the broader point, is that you can call it smoothing, edge split, smooth groups, face smoothing, hard edge, soft edge. It doesn't matter what you call it. It doesn't matter how you enable it, interface with it, interact with it. Those are just user interface options, essentially. They are just ways of managing, controlling, editing, and just implementing smoothing. But at its core, they all work on the same principle, which is that the surface is broken in order to get a hard edge. And by that, you're essentially saying that the surface is no longer continuous, and you can't have a non-continuous surface, or you can't place a non-continuous element in a continuous surface without interrupting or breaking that surface. And in order to do that, you literally have to physically break it. But how you do that, as in terms of the interface, how you manage that as a creator is, it's not immaterial in the sense that that aspect of creating is completely different to what the rendering is doing underneath it. So it can be confusing, but you have to divide your you have to compartmentalize your thinking. So on one hand, you've got what you do in Blender, but on the other hand, you've got what the renderer, the graphics chip, is doing to actually render that to screen. The two of them, they're not, well, obviously they do correlate because you're using your interface in Blender to control what the graphics card does, but in the sense that How can I put this? I can't think of a way to put this other than just how you control it is not the same as what the graphics card is doing or what the graphics chip is doing. And that's where the confusion comes in, because you can manage it quite easily in Blender or Max. We tend to think that when you use Auto Smooth or the Edge Split modifier, that's what the graphics card or the game engine is using. It's not. It has to break down the mesh into its fundamental components, and unless otherwise instructed, it treats all surfaces or all vertexes, all edges, all those core components as a continuous surface. For it not to do that, you have to physically break it, and that's what smooth groups are, or that's what smoothing is. So when you apply the edge split modifier in Blender, for example, so when you apply that, what it does is it splits the mesh, and that is what edge split is, or that's what smoothing is. It's split vertexes. So whilst you can manage your smoothing without applying the edge split modifier, you can mark edges as hard or soft depending on what it is that you want, and Blender will draw those edges hard or soft. That system or that mechanism to do that is not the same as what the graphics card is rendering. So think of it, split your thinking so that you are thinking of what you do and the interface is different to what the graphics card has to do in order to render to screen what it is that you're working on. It depends. I mean, generally speaking, if you don't have smoothing or anything assigned to the mesh, well, you could try it. If you export a cube as a continuous mesh without smoothing, you'll have, 16 vertexes? 16 vertices, I think it is. Or however many vertices it is. But if you start adding smoothing, so if you have all 6 sides smoothed, depending on whether you're using 3D Studio Max or some other sort of proprietary system, the FBX file may be exporting the proprietary smoothing information tagged onto a vertex, so that even though you have 16 vertices, there's a tag that's associated with those vertices that may be read by the program that your destination program, so Unity, Unreal, or IMVU. IMVU can't read that data, so the vertexes have to be split. They have to be physically split. But if you do the same thing in Unity or Unreal, because they're much more advanced game engines and rendering engines, they may read the tag and do all the hard work in the background, whilst you've still only got 16 vertices. So IMVU would well, I guess, what is it, 100 plus vertices, because each face would have 4 vertexes, and that's a lot of vertexes when you consider there's 6 sides and each side has 4 vertexes, and blah blah blah, etc., etc. So IMVU has to split the vertexes, but the FBX file may be able to contain tagged information about smoothing, which other engines can pick up on. So that's the sort of idiosyncrasies that you have to work with. Yeah. Or a flat, yeah. So if you, I mean, that's what I'm saying is that if you have a cube and it's got a single smooth group associated with it, so that basically means right, so that's one cube. That one cube is now smoothed, and that is one group. So all surfaces, all vertexes, all edges, everything that's associated with that cube is associated with that single smooth well, group. Let's just call it smooth group for the ease of use. So that's a smooth group. So that's now two smooth groups. That's now three smooth groups. That's 4, 5, well, 6 and 7 we don't really need to do that, because those two are not joined surfaces, so they are still part of the same group. So we've got one cube. It's actually probably got, so 1, 2, 3, 4, 5. It's only got 5 groups now. But that's what happens. So when you export something like this, each of these is exported. Is exported as a surface. But it's actually rendered like this. In fact, it's actually rendered like this. That is what your graphics card is actually doing. That. In order for it to know, so you've got each triangle is comprised from or of 3 edges or 3 vertices or vertexes. Okay, there we go. So if you wanted a quad, so keep in mind that everything is reduced down to a triangle, right? If you want a quad, or a something that approximates a quad, so we've got 2 triangles, and they are merged together so that, that gives us a face. I mean, it's not a quad because it's not a traditional quad because it's still being drawn as 2 triangles. But what's happened is those 2 vertices and that edge are coincidental and have been merged together in order for it to draw that face. But if you wanted a hard edge along that triangle, along that diagonal, I should say, it has to split those in order for there to be an edge there. Otherwise, it'll generally just draw it as a quad, and the whole box, this whole cube is drawn like that. That's how this stuff actually works from the in terms of what the graphics card is actually doing. That's why when you look at the specifications for a graphics card, they'll say a quadrillion teraflops of whatever it is, because this is what it's doing. Yeah, so now this is where what you're asking now about custom normals relates to the point that was just being made earlier about you have to separate how you as the creator interfaces with the objects that you are working with and the end result in terms of what the graphics card or the graphics chipset or whatever it is actually rendering to screen what you're looking at. They're not related at all, other than just allowing you an interface, a user interface, an easy way of interfacing with all these individual coordinates that are associated with the position of vertexes, edges, faces in 3D space. So my doing what I'm doing right now is an interface thing, but what the renderer is doing is a completely different kettle of fish, because it's just dealing with raw data, raw coordinates. That's it. Yeah, so when you're talking about custom normals, changing the orientation of things, all of that is just an interface. It's just interface and management. That's all it is. It's just you being able to just change something visually as you are looking at whatever it is that you're working on. But what's going on under the hood it's not related in that sense. It's just raw numbers, raw data. But your interface, as in Blender, can create the illusion that you are doing something that you're not actually doing. So that's the point, I suppose, that's being made here, is that what you do in terms of the buttons that you click and the actions that you carry out are just a way of you being able to fundamentally change the coordinates and data structure of numbers, basically. And it's the raw numbers that the graphics card or the chipset, that's all the chipset's concerned with, is just raw numbers. And the simplest of raw numbers is vertex, edge, and triangle. But how you affect those it's different. Yeah, again, so auto smooth is just a method of management, in the same way that edge split is a method of management, in the same way that smooth groups in Max is just a method of management. It just changes the physical appearance of something and makes it easier for us as visual creatures to interface with whatever it is that we're working on. What goes on under the hood is then obviously you're controlling what goes on under the hood, but at the end of the day, everything has to be broken down into its fundamental component, which is vertex, edge, and triangle. But it catches a lot of I wouldn't worry about it too much. It catches a lot of people, and it does cause, from a content creator's point of view, depending on the engine that you're working with, it does cause issues, because you can be working on your project in Blender and it'll work perfectly fine in Blender, and this, in fact, funnily enough, used to be what happened in the early days of before 2.5, and we were still on 2.49. When that change occurred, Blender introduced a number of features that worked in Blender but didn't work in they weren't necessarily available in 2.49, so you could work on producing a model in Blender in 2.5 and do the same thing in 2.49. The one in 2.49 would work, but the one in 2.50 wouldn't, because of a fundamental change in the way that your meshing your objects were all managed. So if you're not careful, it can cause issues and it can trip you up, and it does. But that's just part of the game, I suppose. And with 2.8, there's probably going to be some changes there as well, particularly with FBX. But yes, if all you need to do is just keep in mind that auto smooth, smooth groups, edge split, hard edges, soft edges, all of that sort of stuff, those are just ways of managing what you are visually looking at. At the end of the day, when you export the file, when it gets into your engine of choice, whether that's Unity, Unreal, IMVU, whatever it is, it doesn't matter. At the end of the day, it's all fundamentally drawn as vertexes, edges, and triangles, and then the data structure starts to come into play. So, if the surface is continuous, it'll treat it as continuous, and the smoothing will apply across all the surfaces, or all the triangles, I should say. And in order to prevent that or change that, you have to physically split the mesh. Otherwise, it doesn't know what's going on. And yes, there may be proprietary ways of doing that, but again, fundamentally, that's just basically how it works. It can't work any other way. I mean, in the very early days of graphics cards, and we're talking I can't remember the name of the graphics cards now. In the very early days of graphics cards, the competition or the contest wasn't between AMD and NVIDIA. It was between fundamentally different ways of rendering, particularly transparency. It was a difference between fundamentally rendering what we see on screen. So had NVIDIA, AMD, and the OpenGL pathway not won out, it may very well be that we would be using a different rendering system to draw the same sorts of structures that we do today. But that's, NVIDIA, AMD, OpenGL, they won. Primarily, I think, because they had, it was ATI at the time, not AMD. So that's your cube. Each of these sides is separate. Whoops. So if we remove doubles and assign the same smooth group to everything, because what we've done is we've removed the doubles, we've moved coincidental vertices, so now everything is joined together. And that's what would essentially be drawn in a game engine. Without instructions as to how the edges and the vertexes and the faces are supposed to relate to one another, it'll just draw it like that. Otherwise, it'll split them all. So that's smoothing in not quite so small a nutshell. Okay, so you've explained it, but just trying to get my head around it. That's okay, yeah. But smoothing is something different from geometry. How can one guide the smoothing thanks to supporting edges? So why does it look better when supporting edges are added? I guess that's how. Right, so what you're actually talking about there is still smoothing, but a different way of managing or controlling it. And for medium to higher poly, you know, what we would now, well, what used to be called next gen, but I know it's current gen, been current gen for about 10 years now, I guess. You can do that with increased mesh density. So for low poly environments like IMVU, you've got to weigh up. Hang on, let me just right. So in a low poly rendering environment, you've got to weigh up the cost rendering wise of geometry versus textures or images. So in low poly environments, you're trying to keep both to a minimum. So you have a minimum number of faces, and you try and keep the amount of texture data that's being shoved through the system as low as possible as well. But in those instances where you need to create smoothing, you have to do what we've just been discussing. And that's primarily because vertices or vertexes, however you want to pronounce that, I never know which way is the right way, those are the lowest form of data there is, because it is literally just a point in 3D space. So it's a coordinate. And it's cheaper to split a vertex than it is to add geometry. So for IMVU, for example, and funnily enough, Unity and Unreal and all the game engines, they were all like this in their early days. It's cheaper to split the vertexes and create coincidental vertices to create your smoothing or to control smoothing than it is to add geometry, because adding geometry adds additional overheads with surface rendering and textures and all sorts of other things. So in a low poly environment where you're talking about low resolution meshes, very much like IMVU, or even mobile games now, I guess you could say, it's cheaper to just split edges or to control smoothing through edges, split vertices. So you're creating a hard edge, or the appearance of a hard edge, by doing that. But now, because it's cheap, you can control smoothing by adding additional geometry. So as that edge was slid upwards towards this top, it changed the structure, the visual appearance of this surface at the top. I mean, if you wanted to go the nth degree further, you could, let's try beveling that. So bevel that, that's Control B. Whoops. So we've beveled that, and already looking at the top versus what's going on the sides here. So the top of this and that leading edge is completely different to these edges around the rest of the mesh or the cube. And that's because the additional structure, go away annotations, thank you. The additional structure is distributing the smoothing across more geometry. So it treats the surface as a continuous smooth group, or assigned to a continuous or the same smoothing, but the additional geometry allows that smoothing to essentially dissipate across surfaces. Whoops. Why am I doing that? I want Control R. So if we watch this leading edge in the corner, and how this front face, how this front face changes as you add more structure, we can see that what starts to happen is you change the behavior of the smoothing. And it's doing that because you're adding geometry. So you can keep the object in its single uniform. Oops, we've already got one added there. Or have we? You can keep the smoothing structure or the smooth group, the single group associated with the object, but you can control its behavior better by adding more geometry. So that is now our cube with additional geometry added, whereas compared to mesh, plane, cube. So we've got the modified one on the right and the default on the left. Both have the same single smooth group assigned to them. So that's what adding geometry does. It distributes the smoothing different depending on. So again, if so with high resolution meshes, high poly meshes, you can do the same thing. So let's get a really hard edge on this cube that we've just added, and you literally do that by adding another edge. But the irony is that what you're actually doing is creating a set of coincidental vertexes and edges. The only difference is that you're not splitting the mesh. You don't need to when you do it this way. But in a game environment, you know, you've now, this would be inefficient for a game engine because there's a lot of duplication going on there to get that edge, to get that those hard edges. Whereas it's simpler and cheaper for low poly game engines in particular just to split the edges, split the vertices. So you have around a given face you would have 8 vertices, whereas if you're adding geometry, you've not just got 8 vertexes, you've then got 4 additional edges and 4 additional faces, and those are being essentially rendered in a what would be the way, infinitesimally, very, very tiny, basically. So that's smoothing by using added or additional geometry. Yeah, I can't watch videos and do the stream at the same time, unfortunately. So you'd have to hang on, let's try that. Oh yes, you say weighted normals. So the video that you has linked to is talking about weighted normals. So that goes back to the point we were making earlier. You're just talking, you're just watching or talking there about just an interface issue. It's just a way or a method approach of interfacing with your raw data. That's all that is. They all fundamentally do the same thing, so that on export you'll get the same outcome, which is everything broken down to vertices, edges, and triangles, and then it's reconstructed from upwards from there. So if you need as we were just describing earlier, if you need a quad, i.e. two triangles, and that quad is separated from the rest of the mesh, that is drawn with split edges, split vertices. If you do something to affect the normals, all you're doing is changing the coordinates that's associated with the normal of the vertex. It doesn't change the fundamental characteristics, whether that's a split vertex or not, to create a hard edge. And in order to create an edge of any kind, it needs to split. So modifying the normals, if you're just changing the normals for the sake of, let's say you if you split a sphere in half, where the where the mesh is split down the middle, you're going to get a hard edge. So this is one of those things that's handy for asset creations where you are doing mirrored duplication, because what you can do is create your model, half of it, and then duplicate and flip to the other side. But if you do that, your normals are going to differ down the center. So let's smooth this. Whoops. Right, so get rid of that. So again, another technique of game production. So if this will be a sphere in game, but what you can do is model half of it and then duplicate and flip. Whoops, didn't mean to do it that way. What's it not doing? Right, okay. So you have two halves of the same mesh, and what it does is it creates a hard edge, because again we're talking about split vertices. Creates an edge. So when you start looking at how can you get rid of this edge, oh, that's why, it's because it's a linked mesh. That's why I did it. How can you get rid of this hard edge down the center? Ordinarily, that's quite difficult to do. But this is where your custom normals and editing so it's display. No, it's not display. Where is it? Right, there we go. Actually, what I'll do is right, so this is why, whoops, custom normals are useful, because if we look around, look at the orientation of the normals sticking out from each of these vertexes, they are literally perpendicular to the vertex relative to other vertices that surround it. That gives us a smooth, continuous surface so long as vertexes are surrounded by other vertexes. But at the edge, the orientation of that vertex normal, which is the orientation that the vertex is aligned, isn't the same from the point of view of it being perpendicular to the vertex and neighbouring surfaces, because we're missing vertices on the flip side or the mirrored side of the mesh. So your custom normal, where you would use that is to adjust the orientation of the vertex normals, which are these blue lines, so that you can get a approximate correlation between well, what you're doing is making an adjustment for the orientation of the vertex so that you give the impression, or so the game engine thinks, or it renders that vertex down the center as a continuous surface, as if it's part of a continuous surface when it's not. And that's what custom normals do. And that's how you get rid of edges in instances like this. But you are still fundamentally dealing with split vertexes, edges, and triangles. All you're doing with a custom normal, or making any adjustments to the orientation of a vertex, is just that. You are just altering the orientation of the vertex in 3D space. You're not changing whether it's split or not. So you have to keep in mind, you have to, anything that you do that visually affects what you're looking at is just an interface thing, in terms of it being a facilitator for you being able to adjust the underlying structure, data structure that's used to render whatever it is that you're looking at to screen. So asking why not just change the vertex normals to make it not look flat? Because there's, I mean, if you want to adjust the vertex normal to give it a custom orientation, all that does essentially is makes the smoothing. There we go. It makes the smoothing, it just makes the smoothing behave in a different way. I've never actually tried that, actually, but fundamentally, orientating or reorientating the normals, if that normal, if that vertex is part of a group, it won't do anything. It won't necessarily do anything. The custom normal orientation is generally best used in instances where, pardon me, where you need to control smoothing or the appearance of smoothing along a hard edge. So if you change the orientation of a normal, I think it disturbs. I don't know if it actually creates a smooth. Because if you change the I'm not quite sure how that specifically would work, but to the broader point, normally you're changing the orientation of normals in relation to getting rid of things like hard edges. And again, it's just another trick of game engines, low poly game engines. Yeah, I mean the ability to actually change the orientation of a vertex normal or a face normal is a late addition to Blender. So yeah, I mean I don't know off the top of my head. I don't know what their plans are for that. I mean, it's a plugin, or it used to be a plugin very early. I don't know what they're doing with that. So with Blender 2.8 on the way out, I don't know what's going to happen with that. Anywho, that was a very long, that was a meandering pathway that probably ended us up in a deep dark wood somewhere. So back to the task at hand, which was adding morph animations. Oh right, okay. Well, I've not looked into it, so I'll take your word for that you can change the vertex normals in 2.8. So anyway, back to what we were talking about, which is adding morphs. So yes, wow, that was a long rabbit hole. So for IMVU, if you're using Blender and you're using FBX export, before you assign or apply your morph animation, you have to make sure that any smoothing, edge splits, all of that sort of stuff is applied beforehand. So that would include also likely include auto smooth, because that's locked into the mesh on export to FBX, and because IMVU doesn't understand the edge split stuff, it's just going to lose the morph animation. So I guess it's probably best just to use edge split and hard edges, this thing, mark sharp rather than auto smooth, to make sure that your shape keys animation exports. Right, anyway, so we created our basis, which is the root default. So that's the mesh in its natural condition. We've created 2 additional groups. So we're going to now, all we need to do is select one, go into edit mode with our mesh selected, and we now need to we can use paint select or border select to make our border selections. Likely need to do this because we have split the mesh. Because we have applied the modifier, it's going to change how we can select things. So we want to try normal. That's all right. So we're going to create a shape. Whoops. Probably best to go into vertex mode when you're doing this. So all we're doing is just modifying the shape of the mesh. Whoops, we missed a vertex. So that's essentially one shape or one deformation. We've deformed the mesh, and we can test that in the value slider, and that shows us the edit that we made. So we can do that to both of them. So back into edit mode with our group still selected. And again, just modify the mesh. Exit edit mode. Whoops. And again, test. So we can see. Whoops. Our basic morph. So we're going to add another one. Another edit. So select our second group. Whoops. Just shrink this down. Oh, and we missed a vertex. There we go. Do the same on the other side. And of course, make sure that you are deselecting every time you make a new selection. So that's, whoops, wrong one. Select, deselect, or just use the shortcut key. So again, we can test that group by clicking the value slider. So we've got two keys or shape keys, and in the shape key editor, which is part of the dope sheet. So in the dope sheet, we normally work in the action editor to create our animations. So that's our poses, furniture animation, room animation. So I've just got this set up so that the shape key editor, so there's the action editor, there's the shape key editor. So that's visible so that we can see the two as a comparison. But within the shape key editor, it's dropped in a couple of instances or listings of the shape keys that we created. So each key has an entry in the shape key editor. So to create our sequence, all we do is just modify the values, move the timeline slider, and create a sequence by changing the value of each shape key. And this is a cycling or repeatable animation, so you always have to make sure that your first and last frames are the same. So what is that? That's that one. That's 1 and that's 0. So return that to 0 and put that to 1. And that is a simple shape key animation, and that is literally all it is. So obviously the more complicated, so if you wanted to change the shape of the heart or the main body of the bike or do something else, the handlebars, or just make the whole thing pulse, you can add additional groups at any point, so you don't have to create them first, but you can add them, and once you've added them they will appear in the dope sheet as entries here that then allow us to drop in keyframes. So the analogy is that this is exactly the same as creating an action or a sequence for any other object that's exportable to IMVU. So what we then need to do, let's save this. Let's call this 19B. So that's saved, and we should now be able to export this. So deselect the dummy because we don't need it. And then export to FBX. Export FBX 19. So we can do selected objects in this instance. We don't need apply modifiers. Add leaf bones, disable, and for animation disable obviously NLA strips and force start and end keying, and this obviously forces Blender to create any animation sequences that it finds in the file as a separate well, it treats it as a separate animated sequence instead of plonking them all into the same sequence, and then just export. Now if this doesn't work, I'll eat some chocolate. Right, so derive our product, furniture, go so there's the default. We want to replace that, so FBX import, load FBX, and we want 19B, and as we saw yesterday, one of the tip-offs that if this is done right, if this is done correctly, we won't get that select skeleton root dialog box popping up with all the different options. If that does not appear, then you're halfway there in terms of being error or issue free. So scale 0.01, disable rename, that's blur, we don't need that. Mesh ID 0 because we're overriding the default chair. We've got our materials, they've come in. We can leave all of that. Those are animations that are associated with the node, so that's the bobbing up and down. But the ones that we want, or the ones that we're particularly interested in, are the morph animation bits at the bottom. We may need to do a bit of tweaking to the file because it's still showing, well, it's not still showing, it's showing that the sequence that we created is 239 frames long when it's only 40 or something like that. But the 239 is associated with these. But there's a reason why the morph animation is picking that up. So hopefully, let's test this and see if it works. Well, I know it works because I fixed it last night. So import. So we get the material overwriting, that's fine. Apply changes, and there is our Harter bike. And it's all smoothed, everything's in place, textures are in place. So let's just go straight into the morph and see if that works. So stance.idle, because we want to trigger it automatically, and set this to room. We want same ensemble, and then down in our morph animation section, oh, need a different color because that's red, so let's go with green. So in this section at the bottom, we're going to add our morph animation, which should be available here. So click that, and we have two. I'm not quite sure why there are two listed, but it should work. So let's try loops 0, so that loops infinitely, and then apply changes, and there we have our morph animation. So ta-da, it works. I knew it worked. Doing my nut last night, yesterday when it wasn't working, and it is literally just to do with. So what we can do now, I know, all that mucking about yesterday trying to figure out what was going on. And it literally is just because the edge split modifier destroys. It doesn't matter whether you set that option on export. For some reason, it just it destroys the morph animation on export, no matter what you do in Blender. I don't know if it's the same with Max, whether it does the same sort of thing, but it works. I knew it worked. It was just a question of figuring out what was going on. So what we can do here is Harter bike. So when you sit on the, oh, is it stance.Harter bike? I think it's stance.Harter bike. Oh, hiya, Frenzy. Haven't seen you for a while. Oh, it's not working now. Why is that not working? Let me just double check the... See, just when you think things are going the right way. Harter bike. Yeah, that's right. Actually, I think Frenzy broke it. So this is just a different file version, but I'm just loading that in to just double check the triggers. because that's one of the other annoying things about the create mode tools, is that once you stance.heart-o-bike, is that is it? No, it's not avatar. It should assign to. Nope. That's funny. Stance.idle. That's weird. I have to fiddle with that. It does work. So that's morph animation. But what you can do, which is what was set up with this version. Let me just load in. Whoops, not outfits, clothing. Let's add our 3D widget to the scene so that we can see that the thing is actually bobbing up and down and doing the morph animation. So yes, it doesn't do anything at the moment, but yes, if you wanted to, you could have this thing shooting little heart bubbles as thrusters, or whatever rocket fuel a heart-o-bike would use. So let's add, we've got a custom pose for this. That will be created in another session. So we need to add that file, load FBX, and that is heart-o-bike pose 6. Right, so remember, when you are importing a pose, an avatar pose, it'll give you all of these options depending on what it is that you're doing, but always select the one with 86 bones. And then configure FBX. So we can deselect all of that because we don't need it. Those are the meshes, and we can deselect all of that. Those are the materials, we don't need those. What we need is the figure out if there's a shortcut for this annotation tool. What we need is this stuff at the bottom, the animation. 0.01 scale, that's disabled. Okay, so import. Apply changes. So actions, and we can add this to the same. Oh, actually, no, we can't. Or can we? No, create a new action for this. And this is stance dot. No, it's not. Oh, yes, it is stance dot heart-o-bike hyphen seat 01. So this is a pose that's specifically associated with the avatar, or with the seat node that's associated with the furniture item. So we've now got our animation, and we want pelvis node. No, I don't think that's quite right. So let's just double check this. 0. Apply changes. Oh, and because we've imported another FBX, we have to reset the skeleton. It's not stance, it's what is it? Oh, stance, right, that's right. Oops, there we go. So we need frames 1, 4, that'll do. And there's our custom pose. Yeah, I'm sure someone's already done a heart-shaped hard hat. Although that would be quite funny. So a heart-shaped hard hat on a heart-shaped bike, putting out heart-shaped exhaust. So let's add, I think it's that one. Loop. So that's the bobbing. So the bobbing animation and the morph animation are imported as part of the same FBX file. But you can, as with the pose, you can import that as a completely separate file. But if you do that, you have to make absolutely sure that there's a 100% one-to-one correlation between your morph animation and the physical structure of the mesh, because if there are any differences, as we saw from yesterday and what we were just talking about earlier, if there are any differences, the morph animation may not work the way it's expected to. So that should, there is a way to do that. Stance.seat node hyphen seat number. So action 1 is the pose. Action 0 is the up and down and morph. So we should be able to change that. Stance dot heart o bike hyphen seat 01. There we go. It's working now. So when you're not sat on the bike, it's not doing anything. But as soon as you activate the bike, as soon as you sit on the seat node, it activates the animation. Yes, deflate the heart by. Yes, so I mean, adding an animation like that, so adding hearts or clouds or whatever it is that's being pooted out of the back there, those could be morph animations as well, although that's, you know, not necessarily simple to do, but not necessarily complicated to do either. But those could be morph animations as well. Yes, the exhausts. So there we have. It was smoothing or edge split. It was the edge split modifier that was causing the problem, and we discovered that the long way around through that circuitous conversation about smooth groups and how those work, which is probably a bit in depth, but it's important stuff nonetheless. So there we have our harder bike pooting along, just bobbing up and down. Yes, the rabbit hole. It's quite true, Liana. It's all important stuff to know, though, because we do take it for granted. Rabbit hole, yes, rabbit. So let's save this. Twitch hardback, and this is number 8. So that's morph animation, creating morph animations in Blender. Oh, there is one thing that you might need to make sure that you have in place. So aside from the edge split modifier or smooth groups or whatever it is, make sure that you are dealing with the raw mesh or the mesh as it's going to appear in IMVU. But on export, what you might also need to do is, depending on how you are animating the object, the export process does need an action associated with the project somewhere. Because for some reason, I don't know why this is, and I don't know if this is specifically an FBX issue or whether it's an IMVU interpreting the FBX issue. But there needs to be an action of some sort, because I guess it must be tagging. IMVU doesn't think that there's an animation present unless there's an action. So even though there is a shape key sequence, it doesn't consider the project to have an animation unless there's an action sequence. So you may need to just select an object. It can be the mesh itself or one of the nodes. Typically it might be just the root node for a furniture item, or it might be skeleton.room for a room, and just create a short sequence just so that there is an action available for export. That's one thing that you may need to do on exporting from Blender. But other than that, it's pretty straightforward. So your mesh in its final state, as IMVU is going to see it, in Object Data Properties, you create your shape keys, the first one being the mesh in its raw, well, not raw form, its default form, without any modifications to its shape. You create as many shape keys as you want, rename them appropriately, select the key that you want, go into edit mode, change the shape of the mesh however you want, and then once you've got your shape keys in the shape key editor that's part of the dope sheet, just place the cursor or the timeline slider at a frame, and then just alter the values attributed to those positions, and it'll insert a keyframe, and just repeat that for as long as you want the sequence to be. Haha, thanks for the bit. I'm gonna have to do some custom graphics for you soon, Miyaka. Oh, three cheers. I get you. Yeah, very cute. With Miyaka here, so we can see that there's the difference between how Blender does shape keys and how Max does morphs, because in Blender we don't need to have duplicate instances of the mesh, whereas in Max I think you do. So our shape keys in Max would be another mesh that's referenced as the final well, whatever the shape key is supposed to look like. But in Blender, we don't need to do that because it's just a set of coordinates that are stored or retained within the data block that's associated with each of the shape keys. Yeah, follow the white rabbit. So yeah, that's shape keys. It's Blender's equivalent of morphs, 3D Studio Max morphs. Oh, we've been going for nearly 2 hours. Amazing. So there's a lot. There was a lot covered there. A lot of technical stuff, but the basic process is actually quite straightforward. But just make sure that you are dealing with your mesh when you assign your shape keys in its final form. So any modifiers will need to be applied. So that's not just edge split, but anything that you might have associated with your mesh will need to be applied before you start working on your morphs or shape keys. Questions or topics or suggestions for other topics to cover or other things to look at in future streams? Ideas, that is. Ideas for other... Yeah, quite so. Liana's asking, could we look at avatar poses just for fun? You can look at them, certainly. Not sure about it being fun, though. Now, avatar poses are, again, the basic principle is dead easy to understand. It's just that in order to make them look decent, you do have to spend a bit of time getting to grips with the the armature, and how it articulates and how that articulation relates to the way that the arm bends, legs bend. So, you know, we created a... Where is it? We created a custom pose for our Harter bike. And that was done by just importing the raw elements that are necessary for a pose to position the avatar. So we've got the mesh, and then we've got the seat node and the root node. And both of, well, not both, all of those give us reference points to then bend and rotate the bones to create our pose. And that is literally all we're doing, is just rotating the bones. We don't need to do much else to them because they're already in position. But always the key, if you're making a custom pose, the key to it, whoops, come on. The key to it is to position the seat node that's associated with the furniture item or the room pose. It'd be the same thing with the room pose, although you might have to, depending on what that is, you might have to import the entire room. But the seat node, the origin of that, which we can't quite see because... So the active element. So right in the center there, right there, is the origin. That's there. There are two origins there. There's the origin for the cube, which is the seat node, and there's the origin for the skeleton, which are all these funny bones that are pointing all over the place. And to make sure that your pose matches your mesh, you've got to make sure that those two elements are aligned. And then once you've got that, because that's the rooted position or the baseline position of the avatar, and then once you've got that aligned, you can then start posing your mesh, posing the avatar relative to the mesh, and that's your pose. That's how you create your pose. No, I've not seen your poses yet, Liana. So you'll have to. You can link it in chat if you want. But it can be tricky if you're adding poses to another person's product. You're increasing your challenge. You know, it's like you're challenging yourself at number 11 instead of 10, because you have to match the pose to the object, and you're doing so guessing where the seat node is, because obviously you don't have the original item. But if it's a pose for an accessory, it doesn't matter so much, because you're creating the pose independent of the accessory anyway. But the furniture and rooms, it's a bit more complicated. Oh right, avatar accessory ones. Yes, so that's fine. Those are generally quite easy to do. Right, well that was quite a mammoth one. That lots of talking and explanations, explanatoring. But if you have any suggestions for future topics, what I might do, I don't know if something for the weekend. So what I might do for the weekend, so we'll give ourselves, what day is it today? Wednesday. So Thursday, Friday, maybe Saturday, maybe over the weekend. There might be a stream over the weekend, I'm not quite sure. But what I'll do is I'll take a look at adding pooty hearts coming out of the exhausts, per the suggestions of just about everybody really. Let's see if we can add those using morph animations, and add that as an additional thing to the Harder bike. What are you going to do some IMVU creating streaming Miyaka? Oh, no frozen pipes, yes. Yeah, you guys are getting hit quite hard with that polar vortex. Right, okay, well, yes, so I'm obviously conscious of, doing too many streams and basically, what's the word? Monopolizing? That's not the word. It's the word. But yes, we do need other creators to be doing streams. The more the merrier. Obviously, it's just a question of trying to organise timing. Who's on now and who's on first, what's on second, I don't know, who's on third. Okay, so we'll take a break Thursday, Friday, and then for the weekend, we'll see if we can get some heart to poot out of the exhaust of the harder bike. Right, yes. Yeah. Either that or it's fighting in the background. Yep, exactly. Right, alright then, on that, darn kids. Yeah. If it weren't for you darn kids, would have got away with it. Where's Scooby-Doo when you need him? Right, okay, so we've done 2 hours. It's always best to try and keep these within 2 hours because that means we can easily archive them. So that's the tip for streamers. If you are wanting to archive your streams, just try and keep them under 2 hours. And it makes it easy to do that. Right, so hopefully we shall see you on the weekend. Thanks everyone. Thanks very much for all the questions and the conversations, and the technical discussion doesn't happen very often, but it's very, very, very useful. So thanks to Ju. Thanks to Ju for that. That was quite an interesting conversation to have. And we shall see you on the weekend. So, thanks for stopping by, everyone, and thanks Miaka for the 3 cheers. Hip hip hooray. We shall see you anon. Right, bye for now, everyone.